Assalamualaikum and hi everyone. Today we are going to learn about lecture 2 of 5, topic 6. So in this lecture, you will learn about 6.2 binomial distribution. Learning outcomes in this lecture are: the first one, we need to identify the binomial distribution such that X distributed to B and P. The second one, we need to determine the probability of an event. Next, we need to determine the mean and variance. And the last one, we need to solve problems in social sciences and management. Let's listen explanation from Madam Saadah.
Binomial distribution is used to model situation where there are two possible outcomes, either success and failure. Together with these properties, the following conditions need to be fulfilled. A binomial distribution must have a fixed number of trial, that is n trial. B, the probability of success for each trial is P, and the probability for failure, that is Q, must be constant for each trial. C, the trial, the experiment, is independent of each other. Okay? So this is the three conditions that you need to consider. There are n trial. Each trial has two outcomes, either success, that is P, or failure, that is Q. And each experiment must independent to each other. Okay, now take a look at the first example. Determine whether the following situation can be modeled by a binomial distribution. A, the number of head obtained when unbiased coin is tossed 10 times. Okay, so the trial here is we have a coin and we toss the coin 10 times. And we focus on to get a hit. So this is a binomial distribution because the probability to get hit every time you toss a coin is 0.5. That is constant for each trial. And we have n trial. Okay, 10 times you try to toss a coin. What about B? The number of black pen obtained when 4 pens are picked at random at one time from a box containing 5 black pen and 15 red pen. So we have a box and you want to find, you want to obtain 4 pen one at a time. So this is not a binomial distribution because for each trial, every time you want to pick a pen, the probability are not a constant, okay, because you did not put the pen back into the box. So the trial are not independent. Okay. So now we continue the definition of binomial distribution. If X is a discrete random variable of a binomial distribution, then the probability of X success in n trial is given by probability X equals to X, that is NCX P to the power of X Q to the power of n minus X, where X starts from 0, continue with 1, 2 until n. Okay, take note that X here represent the number of success. Where n is the number of trial, X here there is the number of success. P is the probability for a success. Q the probability for a failure. The relationship between P and Q is Q equals to 1 minus P. Okay. Note that ncx here is equals to n factorial over n over x factorial times n minus x factorial. Okay. Okay, first example. If x is a binomial distribution, the n is 10 and p is 0.9. Find A, probability x equals to 6, B, probability x more than 8, and C, probability x less than or equal 1. We will use this formula to solve. For A, take note here that n is equal to 10, number of trial, and P, the probability for success, is equals to 0.9. A, probability x equals to 6. So out of 10 trial, what is the probability x equals to 6 is, we substitute n with 10 here and C 6. X you substitute with 6. P is 0.9, so 0.9 to the power of 6. Q is 0.1, so 0.1 to the power of 4. Simplify, you will get the answer is 0.0112. Okay, now we continue B. Probability x more than 8 is equals to probability x equals to 9 plus probability x equals to 10. So substitute the value of x, that is 9, into this formula. The value for n and p are still the same. Therefore, we get 10c9, 0.9 to the power of 9, 0.1 to the power of 1, plus 10c10, 0.9 to the power of 10, 0.1 to the power of 0. Simplify, you will get 0.7361. Okay, now we continue C. Find the probability x less than or equal 1. That is equals to probability x equals to 0 plus probability x equals to 1. Don't forget to include 0 here. We will use the same value for n and p. That is n equals to 10, p equals to 0.9. For x equals to 0, we have 10c0, 0.9 to the power of 0, 0.1 to the power of 10, plus for x equals to 1, 10c1, 0.9 to the power of 1, 0.9, 0.1 to the power of 9. The answer is 9.1 times 10 to the power of negative 9. Okay, let's continue on how to read the tables. The table gives the value of the probability of obtaining R or more successes in an independent trial. That is, probability for x more than or equal R is equal to the summation of x equals to R until n and Cx p to the power of x 1 minus p to the power of n minus x. Note that the relationship between p and q is q equals to 1 minus p. Okay, so you have to take note that to read the table, you need to find the probability for x more than or equal R. Okay, there are three values or three parameters needed to find to read the tables. That is n, p, and r. Okay, the table below is the probability in the form of p x more than or equal x. Okay, where x is the number of successes. The table below show part of the probability value that we'll use in this topic. Okay, so note that three parameters that we will use to read the table is n, p, and r. Okay, the first column give the value for n. Okay, n equals to 20. The first row give the value of p. Okay, p 0.1 until p 0.5. The second column give the value for r. For example, n equals to 20, p equals to 0.35, r equals to 7. So, when r equals to 7, n equals to 20, so you intersect p equals to 0.35, r equals to 7, you will get the value for probability x more than or equals 7 is equals to 0.5834. Okay? Okay, now we continue with the same value for n, that is n equals to 20, but the value for p now is 0.5. So, probability for x more than or equal r here is 6. Okay, so you intersect the value for r equals to 6 and the value for p 0.5, you will get the probability is 0.9793. Got it? So take note that you have to find the value for n, p and r to read the table. And please take note that to read the table, you need to find the probability for x more than or equal r. For this example, probability x more than or equal 7 and probability x more than or equal r. Okay? Okay, we continue next example. If x is a binomial distribution, n equals to 20, p equals to 0.06. By using the binomial table, find A, probability x more than or equal 3, B, px more than 3, C, px equals to 3, D, px less than 3, E, px less than or equal 3, F, px more than or equal 2, less than or equal 7, G, px more than 2 but less than or equal 7. Okay, we start A first. Okay, from the information earlier, we know that x is a binomial distribution with n20, p equals to 0.06. So, to use the table, okay, probability x more than or equal 3, to use the table, you need to find what is r here. So, what is r here? R equals to 3. Okay, so you intersect these three value, n equals to 20, p equals to 0.06 and r equals to 3, you will get directly from the table that is 0.1150. Okay, got it? Okay, now we continue B. Probability x more than 3. So the binomial distribution is a discrete random variable. So please take note that 3 is not included here. So what is the integer after 3? We want to find the probability x more than 4 until n equals to 20. Okay, so by using table, take note that 4 is equals to r here. So r equals to 4. So one more time, from the table, we can get the value that is 0.0290. Okay, so for probability x more than 3, you cannot read from the table. So you need to change to x more than or equal 4. Okay. Okay, now we continue C. Find the probability x equals to 3. To find the single value probability at x equal to 3, the formula is given as probability x more than or equal 3 minus probability x more than or equal 4. So how do you get this formula? Probability x equal to 3 is the summation for x equals to 3, 4, 5 until x equals to 20. Okay. This is the value for probability x more than or equal 3. Probability x more than or equal 4 is given as the blue rectangle here, that is the summation from x equal to 4 until x equals to 20. So you need to minus here the probability x more than or equal 3 minus probability x more than or equal 4. Then you will get this value, that is probability x more than probability x equals to 3. Okay, so by using table, you can have the value is 0.1150 for probability x more than or equal 4, 0.0290. Simplify, you will get 0.0860. Okay, so make sure to create the formula for the function to be x more than or equal 3 minus probability x more than or equal 4. Okay, what about D? Probability at less than 3. So you can understand by look at this diagram. This is the total of all the probability from x equals to 0, 1, 2 until x equals to 20. The sum of all the probability is equals to 1. Okay, then the green rectangular here is the summation of all the probability from x equal to 0, 1 and 2, because the question asks to find the probability at less than 3, means 3 is not included here. Okay, so to get the value, you need to minus the probability x more than or equal 3, that is the blue rectangular here. Okay, so the formula is probability at less than 3 is equals to the total for all the probability is 1 minus probability x more than or equal 3, that is the blue rectangular here. So by using table, you will have 1 minus 0.1150, that is 0.885. Okay. Okay, now I'll continue. E, find the probability x less than or equal 3. So the formula is given as 1 minus probability x more than or equal 4, because 3 is included here. Okay, so by using the diagram, you can see that probability x less than or equal 3 is given as the yellow rectangular here, starting from 0, 1, 2 and 3. Okay, to use the table, we need to create the formula, that is the sum of all the probability, that is 1 minus probability x more than or equal 4. That is, you have to 1 minus the blue rectangular here, that is the sum from 4 to 20. Okay, so by using the table, you can read the value for probability x more than or equal 4, that is 0.0290. 1 minus this value, and the answer is 0.971. Okay, okay, what about F? Find the probability for x more than or equal 2, less than or equal 7. Please take note that 2 and 7 are included here. Okay, so one more time, by using the diagram, we can see that x is start from 0 and the last term is 7. 7 are included. Okay, this is the value that question 1, that is the probability from starting from 2 until 7. But we want to use the table. Okay, instead of use the formula. When you use the formula, it is very tedious, because you need to find this 6 value. So better to use the table. So how to create the formula? You need to find the probability for x more than or equal to 2 until 20. That is the green rectangular here. Okay, you have to minus probability x more than or equal 8. That is the sum from x equal to 8 until x equal to 20. Okay, therefore the answer is 0.3395 for probability x more than or equal to from the table, and probability for x more than or equal 8 is 0. So simplify, you get 0.3395. Okay. In order to read the table, you need to create the formula probability x more than or equal 2 minus probability x more than or equal 7. So you need to know how to create the formula in order to read the table. Okay, now we continue G. Probability x more than 2 less than or equal 7. Please take note that 2 is not include, but 7 is include here. Means the question asks probability at x equal to 3, 4, 5, 6 and 7 at this 5 value. Then to use the table, you need to find the probability x more than or equal 3 minus probability x more than or equal 8, because 7 are included here. So you need to minus 8. The answer is 0.1150 minus 0, and the final answer is 0.1150. Okay, now continue next example. In a biology exam, 45% of the student pass. If the class of 20 students took the exam, find the probability that A, exactly 15 students pass, B, at least 2 students pass, C, more than 16 students pass, and D, not more than 1 student pass. Okay, so what is the solution? We start with let. X is the number of students pass biology exam. X is a binomial distribution, n equals to 20, number of students, 5. 0.45 is the probability represent the student pass the biology exam. Okay, so the question asks probability x equals to 15. That is exactly 15 students pass the exam. So, like the previous example, the formula is given as Px more than or equal 16 minus Px more than or equal 16. The net integer after 15 is 16 because the table read more than or equal. So, the answer is 0.0064 minus 0.0015, and we get 0.0049. What about B? Probability at least 2 students. At least you can write in terms of symbol as probability x more than or equal 2. Okay, you can read from the table directly because this is the symbol more than or equal to. So the answer is 0.9999. What about C? Probability more than 16. So write in terms of symbol. So Px more than 16. So please take note that 16 is not included here. So to read the table, you need to change to probability x more than or equal. The next integer after 16 is 17. Then the table will give 0.0003. What about D? Not more than 1 student pass the exam. So not more means probability at must less than or equal 1. 1 can be included here because the question asks not more than 1. Okay, so like the previous example, you need to do the subtraction here. 1 minus probability x more than or equal 2. That is 1 minus 0.9999, and the answer is 0.0001.